Can recognize, oh yeah, I did use a Tony variable and I did type as parameters. And then for the adventurers, they can make some changes to this and go back to 12 blocks so that they really see that this is not abstract, that everything makes sense, that there's no magic involved, that at the end of the day, we're using the basic commands that the designer gave us to get something done. And it's just a way of making it less abstract. And for example, to get this program to go, I had to include these different objects, and I had to use this var section there, and I had to do this clock mode equals crystal 1 plus PLL 16x. So that's how you typically program these types of microcontrollers. But in here, it just looks more colorful and prettier. Okay. All right, so we've seen what they look like. Lunar lander, so you can do graphics with this too. Plug a VGA into a propeller, and then you can do video games on there. There's lots of things that you can do. Curriculum, starting at primary school, high school, university. We call one part of this one robot. Mission is similar to this one laptop per child, and it's more one robot per classroom, where there's robots and there's curriculum built around them, so that there's a software piece, 12 blocks, there is the hardware piece, the T-bot, and then there is curriculum that I'll show you a little bit of right now, that is designed to make all of this a seamless experience for a novice teacher who's coming to robots for the first time. I know that for the last 50 years, there's been people teaching robots in classrooms, but it's not a lot because it's very difficult. So I'm working at the University of Canterbury. Microsoft? Yep, okay. So they put together things like this, that they have some video, and New Zealand is known for its standard of education and the standards and achievements. So it's this big book, big Bible, where it says 2.44 is error control coding and 2.45 is something else. And what they're doing is they're translating these requirements into activities that can be done with kids. This particular one is for year 12 kids, so quite advanced, and it needs some apparatus. And there's 25 pages of this where it really helps get teachers get started and understand everything, helps understand where students may go awry, and then gives them the tools to judge if everybody has learned everything. So it's something that these teachers can roll out over the entire school system. And it maps all of these activities back to these standards, and then shows you how in 12 blocks you can do these different type of things. And yeah, so it keeps going. And this particular one is using 12 blocks to go back and forth and read the black and white squares and then calculate parity on it. So it's playing a game with the kids, so that they can take a square off, and then the robot can speak out what happened. So it's a pretty cool result. And all of it at the end looks like this. So it's a little bit more than 12 blocks, but not a lot, given that the robot has to go back and forth and has to solve the parity and has to recognize what squares are underneath it. Okay, moving on. Curriculum. So there's also other people that are converting other educational resources to 12 blocks. 12 blocks is a good common language where you can take the same program that you've written, that we just wrote with the Tony variable, and target it to different processors. Of course, if the processor doesn't have all the hardware or it doesn't have the robot-like extensions, then you'll have issues. But for simple programs, you can take the same 12 blocks program that you've written and just save it or just run it on different platforms. It's running on Windows, Mac, and Linux. Processors are the ones I've mentioned. There's also computer vision in there, fiducial markers. Skype is integrated, so with Skype you can connect to 12 blocks and ask what the variables are doing and set variables and look at sensors and all that. ROS, so it's a ROS node where each of the shared global variables are topics and publishers and subscribers and all that ROS language. XML RPC is in there as well, so you can use it as a server. There's more blocks coming every day, and you can import spin or 12 block into other programs, so you can build bigger programs by using things. T-Bot, so there's a picture a couple days old of a whole bunch of frames in a box, and tomorrow we're producing 50 of them in a standard factory. It's a propeller and Arduino all together on here. So there's the Atmega 328, does that make sense? Yeah. Charge via USB, shield on the bottom, the LED, whole bunch of sensors, louder speaker, thanks to my dad today. Viewport, I'm not going to get into that, you can talk to me. Prop scope, $199 with the big book, and I'm working on a new book, Advanced Control Robotics, to be published later this year. Thank you very much.
So we open it up to some questions.
One.
You said something about America's Cup there. Have you ever heard of the NZL 40 in Auckland?
Yes, I was on it a month ago.
Well, I sailed on it about 10 years ago.
Okay.
Yeah, nice ship.
We're close to a big company that's involved in that, so I can't talk too much about my involvement in Oracle.
So is this available for purchase?
The 12 blocks has been out for 2 years, year and a half or so. And the T-Bot, we're just finalizing the price, but yes, we are building them, and I'm taking 20 of them back to New Zealand in 2.5 weeks, so by then we'll open it up.
2.5 weeks?
Yep.
What is it? Is there a website for T-Bots, or is it all under
So
HannoWare?
HannoWare gets you to
Everything.
all my projects.
Okay.
12 blocks is specific to programming, and one robot is this. We're trying to get robots everywhere. But HannoWare lists all those things. And I read the list, so if you write Hanno in there, I'll find it. There's a lot of traffic on the list, so I might not get it every day. But yeah, I love emailing. I have my favorite thing about what I'm doing now is I get in my office and check mail, and then there's people using my product somewhere in the world and doing something really cool or contributing. So.
Last quick question: is there a book, an instruction book that you start people with, like a?
Yep.
Okay.
Yep. So there's a T-Bot overview, 2 pages that sort of just gets you started, but then there's also a 20-page that starts you with plug the cable in here and then go from there.
So is 12 blocks free, or how much does it cost?
I wish I could do everything open source, but no. So 12 blocks is $79.
2 questions. One, is there a demo version of 12 blocks at this time?
Yes, there's a 30-day free trial.
30-day free trial. And how different are the libraries between the Propeller and the NXT, for instance?
Right now, a lot.
Right
So
now.
the infrastructure is there for most of other platforms. So I do have people who've deployed it in classrooms. So there's 20 PCs in one classroom using it for pickaxe.
Okay.
But on the NXT, there is a couple blocks, and there is a block where you can type any code.
All right.
But I'm adding more, and community people are adding more as it goes.
All right.
And it's all, so it's not open source, but there's a whole bunch of XML files, and someone actually contributed support for pickaxe. So I didn't do it. Someone used my XML files, and then one day approached me and said, hey, I need a pickaxe, so I did it. It's like, oh, cool. Yep.
Did you use both the Propeller and Arduino and the T-Bot at the same time?
They were used during my demo at the same time, so I like programming the propeller, and so I use the Arduino as a coprocessor to handle the analog I/O. But the way we have it configured, they're both sharing the same memory, and so you can also program the AVR and use the propeller as a digital coprocessor. Keyword matching. So last year what I showed was having 2 robots and using the Zigbee connection and having this whole concept of of shared memory. And so what more advanced university age kids are doing with this is they have multiple of these bots, and they're all sharing this global memory. That's one of the functions that 12 blocks provides. And they're then writing their measurements into this global memory, or writing instructions into this global memory, which can also be viewed and graphed with 12 blocks. And then based on that, doing really advanced cooperation and cool things like that. So if you want to buy 2 teapots or 5, you can do 2.
You said that with the 2 processors share RAM, what about the peripherals? Do they both have access to all the sensors, or either both mode, or
So if you want, you can write your own firmware for both of these. But
so from the hardware point of view?
From the hardware point of view, it's mostly the flexibility of what the Arduino and the propeller makes it that there is not a lot of supporting hardware. That the RGB light is driven by the pins of the Arduino, that the wheel encoders are read directly by the propeller.
So certain peripherals are connected directly to one or other of the processors.
Yeah, and then it's memory, and then you do with it whatever you want.
So your executive firmware manages all of that as dumps status in memory.
Yeah. So the values and the commands are in memory, and then especially with the propeller, you have different cogs that can then write to that global memory and do whatever you want. Yep.
At the beginning, I thought you said the 12 blocks had been around for 20 years, and then later you said you called this 12 blocks. So what did I hear wrong?
Visual languages, like used in the App Inventor, like used in MIT Scratch, like used in 12 blocks. So the concept of having a block and instead of text code. So there is text languages like C and BASIC, and then there is visual languages where there's some metaphor that's visual. And so I have not invented visual languages, they've been around. I hope I've taken some of the good concepts of some and combined them into 12 blocks. So I am the author designer of 12 blocks.
Okay.
Any other questions? If not, let's give Hanno a big hand.